Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new topic named function. So, in this part, we will study about its definition, okay, and like how we can judge whether it is function or not. So, let's crack this situation. Now, first, we will try to understand the definition of function. So what is the definition? So suppose that we guys have set A, okay, and we guys have set B. So there will be two sets which will be involved, okay. Now the definition is for every element of set A must be associated with unique element of set B. Okay, you can remove this for. So we have every element of set A must be associated with unique element of set B. Okay, means first try to understand that you should associate every element, means every element of set A must be associated, and it should associate with only unique element of set B. What does this means? Means you should connect element of set A with only one element of set B. Okay, now look at this. I'll be giving you some situations and you have to judge whether it is a function or not. So suppose that in set A we have these three elements A, B, C, D. Now look at this. I am connecting 1 with A, 2 with C, 3 with C, and 3 with D. Now, do you think it is a function? No. Why? Look at this. The person 1 is having one friend, that is A. The person 2 is having one friend, that is C. But if you'll focus on 3 now, the person 3 is having two friends, that is C and D, which is not allowed. You should associate every element of set A must be associated with unique element in set B. So 3 cannot have multiple friends. So this is not a function. Okay. Now look at this situation. 1, 2, 3, A, B, C, D. Now I am connecting 1 with A, 2 with D. Now what do you think? This is a function? Exactly. It's not. Because in the definition they have given us every element of set A must be associated. But 3 is not associated with any of the element of set B. So it is not a function. Okay. Now 1, 2, 3, A, B, C, D. Now look at this. What do you think? This is a function or no? Exactly. Yes, it is a function. How? Because look at this. Every element of set A is involved. 1, 2, 3 is being involved. Okay? Now, if you will observe, 1 is associated with one friend only, that is A. 2 is associated with one friend only, that is A. 3 is associated with one friend, that is A. So this is a function. You cannot say that sir A is having multiple friends, so it is not a function. No, it's not. You have to focus on set A only. Okay? So this is a function. Now, this is the technical definition of a function. Okay? Now suppose that if I will be giving you the graph of something, okay, and you have to judge whether it is a function or not. If I will represent this thing diagrammatically, you can judge. Now I'll be giving you the graph of a function, graph of something, and you need to judge whether it is a function or not. So suppose that I have given you this situation. Now what do you think, it is a function or not? It is not a function. How it is not a function? Try to understand. If you want to judge a graph whether it is a function or not, you should apply vertical line test. Now what is vertical line test? Means you have to apply so many vertical lines. Okay, you have to apply infinite number of vertical lines and you have to just observe. So if you are having one cut everywhere, this is a function. But if you'll observe here, function is having multiple cuts. So if your function is having more than one cut anywhere, it is not a function. So vertical line test determines whether the given graph is a function or not. Graph is a function or not. Okay. Now one cut everywhere, it's a function. Okay, more than one cut anywhere, it is not a function. Okay, so this is the condition for, like, if you'll observe, you can directly say that sir it is not a function because it is having more than one cut somewhere. So how will you judge why it is not a function? Because look, these things, the set 1 is domain, the set B is codomain or range. If you'll observe, for this input, function is producing this output as well as this output as well as this output. For a specific input, you are having multiple output, which is not possible. For a specific input, you cannot produce multiple output. Okay, so if it is one input, one output, it's correct. Okay, so this is the idea of function. Now we will talk about some graph of a function, okay, which you have to memorize for time being. Okay, later every dot will be connected. Now, so before handling graph of linear function, first try to understand what is domain, and range. So domain is set of all acceptable values of x. Okay, or you can say that projection of graph on x-axis, means you have to take shadow of graph on x-axis. Then we will be having range. Range means its output. Okay, set of all obtained values of y. So this is your range. Second definition will be projection of graph on y-axis. Okay, so this is the definition of domain and range. Suppose that, how will you understand a function? So you can consider function as a machine, like suppose juicer machine. Okay, so you have juicer machine. So you can say that, sir, if you'll give any input, it will give you corresponding output. Okay, now those valid inputs those valid inputs will be considered as domain. So suppose that you wish to put mango pulp, so you can put mango pulp into juicer machine, so that is domain. And if you'll give mango pulp, it will give you what? Mango juice. So that is output, that is range. Okay, now if you will put coconut pulp, you cannot put coconut. Okay, you have to put pulp, otherwise your mother will give you better treatment. Okay, so you cannot do that. So coconut pulp will be the domain and output will be coconut juice. Okay, and there are so many things like watermelon cubes. Okay, you can take that as valid input, and corresponding to that you will have output as watermelon juice. Okay, so this is the definition of domain and range. Okay, you cannot put like nut bolt into the juicer machine. Okay, again you will get better treatment if you will do so. So valid inputs, acceptable inputs is known as domain. Okay, we will understand these things one by one, but for time being try to connect with this definition as well. Okay, now back to the linear function. So from childhood days you guys have drawn graph of linear function. Suppose that we have this as the linear function. Okay, so if I'll ask you to draw a graph of a linear function, what you will do? Sir, I will put x as 0. So if you'll put x as 0, you will be having 0 comma 1, and then you will put that point on the graph paper, the Cartesian plane. Suppose y is 0. So if y is 0, x will become minus 1 by 2. So minus 1 by 2 comma 0. Now what we will do? We will connect these two points via straight line. So this thing will become the graph of a linear function. It's a straight line. If you will apply, like I am calling this as linear function, why? Try to understand. If I will apply vertical line test, it will pass everywhere. Look at this. It is having one cut everywhere. So it's a function. Okay, I hope this part is okay. Now if I will talk about the domain, you know that domain is projection of graph on x-axis. Now suppose that, like you have to take shadow on x-axis. So what you will do? You will switch on the light from this side, then only you will have shadow. So if you will switch on the light from this side, the light which will strike over here will be reflected back, will be reflected back, है ना? Okay, will be reflected back, and the light which will strike this part will be brighten up. Okay, you will have light over there. From here it will reflect. Okay, so the dark part will represent the domain. So look at this, here things will be dark, so this part will be considered as domain, projection of graph on x-axis. Now you have switched on the light from the top side. Now you have to do the same game with below part, means you have to switch on the light from this side. Now if you will switch on the light, you will put light, it will strike back, strike back, strike back, strike back, it will pass, means you will have some light on the x-axis and something will be reflected back. So the part in which light is not there is the part of domain. So if you'll observe in case 1 and case 2, you guys have dark everywhere. So can I say that domain is minus infinity to plus infinity, both open? At infinity you should put open bracket. Okay, now think about the range. So range is you have to switch on the light from this side. So if you will switch on the light from this side, this part will be dark. If you switch on the light from this side, this part will be dark. Okay, so the dark part will represent the range. So if you'll focus, you darken like whole y-axis, so it is again minus infinity to plus infinity. So this is the range and domain of linear function. I hope this part is clear to you guys. Okay, now let's move on to the next function. Now we have quadratic function. So look at this. Your quadratic function will carry this. Suppose that you have f of x equals to ax square plus bx plus c. A is not equal to 0 and like a, b, c A, B, C belongs to real number. Here also you can put this restriction that f of x is equal to ax plus b. A cannot be 0 and a comma b will be real number. So a cannot be 0 because if a is 0, this thing will become constant function. Okay, this is your quadratic. So some points you have to memorize. So suppose that the first condition is you have to memorize that if a is greater than 0, okay, the coefficient of x, if a is greater than 0, you will be having happy face, upper opening parabola. Okay, or if a is less than 0, you will be having sad face, lower opening parabola. So your graph will be either upper opening parabola or lower opening parabola. Okay, so this is the first point which you have to memorize. Now the next point is graph will always pass through 0 comma c. So you know that while drawing graph, we in general used to take x as 0. So if you put x as 0, this thing will become 0, this thing will become 0. So you will be left with c. So graph will always pass through 0 comma c. Then we have another point, vertex. So vertex will be at minus b by 2a minus d by 4a. So this is the vertex. Vertex means it's a point at which graph changes its behavior. Okay, behavior means, try to understand this part. It was decreasing, decreasing, decreasing. Suddenly a point occurs, increasing, increasing, increasing. So this is the idea. Okay. Now, if you want to understand this thing, you can go and watch quadratic equation playlist. Okay, you will understand over there, but for time being just memorize that the vertex will be at minus b by 2a minus d by 4a. So this is the idea to draw graph of quadratic function. Okay, now we have one more situation, that suppose d is greater than 0. So you know that in this case you will be having two intersection points. So your graph will be either like this or like this, means you will have two intersection point on x-axis. Suppose that d is equal to 0. So if d is equal to 0, your graph will touch x-axis. Okay. So your graph will touch x-axis. Okay. Now suppose that d is less than 0. So if d is less than 0, you will have no touch, no cut case. Okay. Here you will have two cut, one touch, no cut, no touch. Okay. Now let's move on to the next function, that is x power. And here if you'll observe the graph, if you will talk about the domain and range, you will find that d belongs to, so if you will switch on the light, suppose you have upper opening parabola, so if you switch on the light, you will have dark everywhere. Okay. So domain will become minus infinity to plus infinity, minus infinity to plus infinity, and the range will be at vertex, it will change. So if it is upper opening parabola, your minimum value will be minus d by 4a to infinity, and if it is lower opening parabola, it is minus infinity to minus d by 4a. So this would be the range. Now look at this. So you have to draw a graph of x power n. So suppose that you have already studied x power 1 how to handle, x power 2 how to handle. Okay. Now I will be explaining you if you have to draw x cube, x power 5, 4, these kind of things. So try to understand if n belongs to 2n type number. Okay, means even number. You know that the degree of the polynomial decides the number of zeros. So suppose that it is 2, 4, 6, 8. So you will have that many zeros. Okay. So suppose that you have a function which look like x power 2, x power 4, x power 6 and so on. So if I'll ask you what like at minus infinity you will have what? You will say, sir, it is plus infinity. Okay. If I'll ask you what is the value of a function at plus infinity, so you will say, sir, it is square, so you will have plus infinity. Now look at this, x square. So hopefully you will have two roots. So two roots means what? Two real root. Suppose means there exists two real roots. So you will intersect your x-axis twice. So this way you will draw your graph if both roots are real. Now suppose x power 4. So again you will start from here only and you will end at here only, but you will have 4 zeros. So 4 intersection points. So your graph will be this, this and this, means 4 intersection. Suppose that the power is 6. So you have 6 intersections. So you will start from here, end at here. So again 1, 2, 3, 4, 5, 6. So this way you will be drawing if it is like leading coefficient is positive. Otherwise you will go this way and so on. Okay. Now suppose that n is an odd number. है ना? So if it is like if the leading coefficient is positive, your graph will start from here, end at here, and you will do something in between them. If leading coefficient is negative, your graph will start from this point, and in between them you will intersect that many required points. So suppose that it is odd number, है ना? Means your f of x will look like x cube, x power 5, x power 7 dot dot dot. Okay. So if I'll ask you what is the like what is the value of your function at minus infinity? So you will do minus infinity ka cube, you will find it is minus infinity. If I'll ask you what is the value of your function at plus infinity, so you will say sir it is plus infinity only, hai na? Now if you are handling x cube means you will have 3 roots, so you will intersect x axis thrice. So this is the graph. Suppose your function is having 5 degrees, so 5 roots, 1 2 3 4 5 7, so it is 1 2 3 4 5 6 7. So this way you will be drawing graph. Now if leading coefficient is positive, your graph will start from here, end at here. If your leading coefficient is negative, then your graph will start from here, end at here. You can substitute the value and you can judge whether it is correct or wrong. Okay? So this is how we will draw a graph of x power n. Now we have exponential function. So what is exponential function? So your function will look like a power x. Now you have to understand that, sir, a should be 0 to 1 union 1 to infinity. You cannot put a as 1. If you'll put a as 1, it will become constant function. Okay? So this is the idea for the given part. Now, suppose that your a belongs to 0 to 1. Okay? So your exponential function will be decreasing. Suppose that a belongs to 1 to infinity, your exponential function will be increasing. Now look at this. So case 1. So a belongs to 0 to 1. Wait a moment. Now suppose that a is in between these two numbers. So I am taking 1 by 2. So if you'll talk about 1 by 2 power infinity minus infinity, suppose. So I'm asking you to find out the value at this point. So what you will do? Sir, I will put 1 power minus infinity and 2 power minus infinity. So this thing is 1 and this power is like negative, so I can send it to numerator, so it will become 2 power infinity. So 2 power infinity is a positive number and it's a big number, so your graph will start from here, correct? Now if I'll ask you to find out the value of your function at x equals to infinity, so sir, I will substitute 1 power infinity, 2 power infinity. 1 power infinity is 1 and 2 power infinity is a very big number. So 1 divided by very big number is very small number. So your graph will look like this. Okay. And this point is a point where x is 0. So suppose x is 0. So if x is 0, you know that any number, any valid number to the power 0 becomes 1. So it is 0 comma 1. So this is your graph of a power x if a belongs to 0 to 1. Now suppose that we have this case 1 to infinity. You cannot put 1, okay? So suppose we have taken example as 2. So 2 power minus infinity. So what will be the value of this function at 2 power minus infinity? So you will say that sir it is negative, so send it on the denominator. So you will say that sir 2 power infinity is a very big number, so it is infinite, so 1 by infinite is close to 0. So your graph will start from here. If I'll ask you what is the value of a function 2 power x at infinity, so you will say that sir it is infinity. So your graph will look like this. Okay, and if I'll ask you what is the point, you will say that sir here x is 0, so 2 power x, 2 power 0 is 1, so 0 comma 1. So this is the graph of your exponential function in the room. If the base is 0 to 1, this, and if the base is 1 to infinity, your graph will look like this. Okay, let's move on to the next function, which is logarithmic function. So suppose that we have f of x as log x base a. Now try to understand this part. Your a should be positive number 0 to 1 union 1 to infinity. You cannot put base as 1, and base of the log should be positive always. Also, you should keep this thing in your mind that x should be a positive number. So this is your graph. This is your domain of a function log x. Now suppose that a belongs to 0 to 1. So if the base of the log is 0 to 1, your function will have this graph. Okay, and this point will be 1 comma 0. So this is the idea when a belongs to 0 to 1. Now try to understand that if a is greater than 1. So if a belongs to 1 to infinity, this time your graph will be increasing. This is the graph of logarithmic function. Okay, and this point is again 1 comma 0. I hope this function is clear to you guys. Okay, now we have signum function. So your function will look like f of x equals sgn x. Okay, now if I'll ask you to draw a graph of signum function, first you will say that, sir, what is the input? So suppose that input is 0. So if input is 0, output will be 0. If input is positive, output will be 1. If input is negative, output will be minus 1. Okay, so domain is minus infinity to plus infinity. Range will be minus of 1, 0 and 1. So this is the domain and the range of signum function. I hope this function is clear to you guys. Now let's move on to the next function. We have this. So f of x equals to x plus 1 by x. You can imagine this function as sin x plus 1 by sin x plus cosec x, tan x plus cot x. So you can connect with this function. So first what you have to do, you have to draw x axis and y axis, and then you have to draw y equal to x. So this is how you will draw this straight line. This is dotted line. I will explain you what does this means. So your graph will initiate from here. It will hit this and it will go back. Okay. Your graph will come from here. It will hit. It will go back. So what is this point? This is the minimum. Minus. Wait. So it will become 1 comma 2. It will become minus 1 comma minus 2. Okay, so this is the graph in which your, like, if I'll talk about the domain is what? Domain belongs to minus infinity to 0 union 0 to infinity. If you put 0 over here, it will become undefined. Okay, now for the range you can say that, sir, it is minus infinity to minus 2. Minus 2 is yes, infinity is no, union 2 to infinity. So this is the domain and range for the given function. Okay, now we have greatest integer function. So what is greatest integer function? Try to understand. So we have f of x equals to GIF x, or I will be substituting this thing, box x. Okay, now suppose that you have to draw a graph of a box function. So how will you respond? So what I will do, I will be giving you a certain number. Then what you have to do, you have to imagine yourself on the number line at that point. Okay, and then what you have to do, you have to move towards left hand direction in the search of an integer. Suppose it is 5, it is 6. So you have to move towards left hand direction in the search of integer. The first integer which you will get is the answer. So this is the greatest integer. Okay, you can also say that, sir, I can break any number x into box of x, greatest integer, plus fractional part x. So this is very important. What is fractional part x? We will study that thing soon. But suppose in any question, if you got stuck, you should take help of this idea and then your things will be done. You can also call this function as step up function. Why you call this function as step up function, you will understand soon. Look at this. Suppose that I have 1, 2, 3, 4, minus 1, minus 2, minus 3. Suppose that I have given you a number between, like I have given you 0. So what you will do? You will imagine yourself at 0 and you will try to move towards left hand direction, but you are exactly at 0 now. Suppose that you wish to have paneer and you guys are on dining table. So on dining table, if you have paneer, why you will move to kitchen? Correct now. So if you are having integer, the output will become the same. Suppose if I'll give you 0.1, again you will say, sir, from 0.1 I'll move towards left, I will find 0. So 0, 0, 0, and the moment I will say 1, you will say that, sir, it is 1. Okay, from 1 to 2, if I'll give you any number, you will move towards left hand direction and you will always find 1. At exactly 2, you will be having 2. So from 2 to 3, you will keep on answering 2. At 3, you will be answering 3. So from 3 to 4, you will be answering 333. Now just behind 0, if I'll put any number, I ask you any number, you will answer me, sir, it is minus 1. Just behind minus 1, you will answer, sir, it is minus 2. Just behind minus 2, you will answer, sir, it is minus 3. I hope this part is clear. So if you'll observe, the domain is minus infinity to plus infinity. But if I'll talk about range, you will say that, sir, it is integers. You can put the shadow and you can observe. I hope this part is clear. Now we have fractional part function. So how does fractional part function look like? So your function will look like this x. This is very important. We call this as a fractional part function. Fractional part function means it should be positive always. Like, try to understand the rational number and the fraction. What is the difference between rational number and fractional part function? You know that rational number is a number which is written in the form of p by q, where p and q are integers, where q is not equal to 0. So this is rational, correct? But if you'll observe 1 by 2, it is also rational. But whether it is a fractional part fraction or not, so it is a fraction. Why? Because fractions should be positive always. Like, try to recall the chapter that you have studied in your childhood days, that is fraction. Over there you must have studied about a pizza. You have divided your pizza into some parts and then you have eaten that thing, correct? No, so 1 by 8, 2 by 8, 3 by 8, 7 by 8, है ना? So this is the idea. So fraction is a part of something. So part of something cannot be negative. So fractional part function should be positive. Now let's try to draw a graph of a fractional part function. So this fractional part function is also having problem at integer 1, 2, 3, 4, this is 0, minus 1, minus 2, minus 3. Now suppose that from 0, if I'll give you 0, you will say that sir, I will break this 0 into integer part and fractional part. So 0 is equal to 0, so fractional part is also 0. If I'll give you 0.1, you will answer sir it is 0.1. 0.2, answer is 0.2. 0.3, 0.3. 0.4, 0.4. So whatever I am quoting, you are answering the same thing. But the moment if I'll quote 1, you will say sir it is 0. Correct? From 1.1 you will say it is 1. Sorry, 0.1. 1.2, 0.2, 1.3, 0.3. So you will keep on saying this thing till the time I am saying 2. The moment I'll say 2, you will say sir it is 0. So 2.1, 0.1, 2.2, 0.2, and you will have graph which will look like this. Okay, if you'll draw, you can understand here. So what is the domain? Domain is minus infinity to plus infinity, and for range it is 0 to 1. 0 is yes, 1 is no. So this is the graph of fractional part function. Okay, now try to understand trigonometric function. You have already studied these trigonometric function. So for formality, I'll be going through one by one. So sine function. So do you remember your graph will have lobes? Upper lobe, lower lobe, upper lobe, lower lobe. You need not to memorize all the points, but try to have a rough point. So this point will be pi, 2 pi, 3 pi, 4 pi. This is minus pi, this is minus 2 pi, and so on. So this is the graph of your sine function. I hope you know about its domain and range. Let's move on to the next function. F of x equals cos x. So cos x function also look like same, but it has problem like this bubble will have from here upper lobe, lower lobe, upper lobe, lower lobe, and your graph will go this way. This is your pi, this is 2 pi, this is 3 pi, minus pi, minus 2 pi. This is your graph of cos function. Now we have tan function. So f of x equals tan x. So your graph will look like this. Tan function is having problem at pi by 2, minus pi by 2, 3 pi by 2, minus 3 pi by 2. है ना? And your graph will look like this. Okay, this will be a dotted line. This dotted line is asymptote. What is asymptote? Asymptote is a straight line towards which graph will approach indefinitely. Okay, this is the asymptote without touching or crossing it. So this is the graph of your tan function. Okay, now let's connect with cosec function, cosec x. Okay, so just you know that cosec function is reciprocal. So pi, 2 pi, minus pi, minus 2 pi. So your graph will have this part. You will have this thing. Okay, at pi you will have asymptote. At 2 pi you will have asymptote. Minus pi asymptote. Minus 2 pi asymptote. Okay, I hope this is okay. So this is cosec function. Now we have f of x equals sec x function. Same game. This person will have problem at 90. Okay, this is the graph, this is the graph, this is the graph. This is minus 1 and 1. Now f of x equals to cot x. So cot x means tan becomes 0 at 0. So at 0, pi, 2 pi, this function will have problem. Okay. Your graph will come, go this way. And this integral multiple of pi will behave as asymptote. Okay. It's a straight line towards which graph will approach indefinitely without touching or crossing it. Now we have inverse trigonometric function. So for formality, I'll go through each and every one. So f of x is sine inverse x. So your sine inverse x function will look like this. This is minus 1, this is plus 1, this is pi by 2, and this is minus pi by 2. So this is your sine inverse function. Now we have f of x as cos inverse function. So cos inverse function graph will be above only. So this is your graph of cos inverse function. This is 1, this is minus 1, this is pi. And then we will be having tan function. So f of x equals tan inverse x. So the graph of tan inverse x will look like this. This thing will become asymptote, pi by 2. This is minus pi by 2. It is asymptote. Okay. Now you have to handle f of x equals cosec inverse x. So what does cosec inverse? So the point at which your graph of sine function ends, you have to start from there. You have to memorize these graphs. These are super important. Okay, so 1 minus 1. So from 1 you will have this. From minus 1 you will have this. Okay, this is the graph of cosec inverse x. Same way we have sec inverse x. So the point at which cos ends, you have to start from there. So you will have problem over here. So it ends here. So your graph will go this way. It ends here. So your graph will go this way. This is 1. This is minus 1. Okay. Now f of x equals cot inverse x. Your graph of cot inverse x will be above only. Okay, we will study these things in detail in inverse trigonometric function, but for time being, memorize these graphs. These are must. Okay, now let's move on to the next part. So we have linear by linear. So suppose that you will have a question which will have linear function on the numerator and the linear function on the denominator. So how will you respond? So you can convert your question into xy equals to c square. So either this situation you will create, or you will create xy equals to minus c square. So you have to create by doing some manipulations, and you have to create this situation. So if you will create xy equals to c square, your graph will look like this. Wait. So you will have a graph in the quadrant 1 and the quadrant 3. So this is the graph of linear by linear. For time being, memorize, later I'll make you comfortable. This is the graph. Okay. Now you know that we have handled circle, straight line, circle, parabola, ellipse, hyperbola. So your circle will look like x square plus y square equals to r square. So it's a circle whose center is at 0, 0 and radius will be r. If you will have x minus a whole square plus y minus b whole square is equal to r square, you will say that circle is having center at a comma b and radius of the circle is r. So these things you have to memorize. Circle is done. Now you have parabola. So y square equals to 4ax. Hope you remember this parabola. So if y square equals to 4ax, your graph will look like this. This is a comma 0. Okay. If you have y square equals minus 4ax, so your graph will look like this. Okay. So this is your graph. Now, suppose you have x square equals to 4bx. So you will have upper opening parabola or lower opening parabola. So your graph will look like this. Although you have studied this thing, but for formality I am going through this thing one by one. If it is y square equals to minus 4bx, x square equals to minus 4, this is y, okay. Four by 4by. So this is the graph. Okay. Now ellipse. You know that ellipse will be like this: x square by a square plus y square by b square equals to 1. So if a is bigger than b, you will have horizontal ellipse. Okay. And if a is smaller than b, you will have vertical ellipse. Okay. Just try to recall these things. These things are must. Okay. Now let's move on to the next part. We have hyperbola to handle. So hyperbola will look like x square by a square minus y square by b square equals to 1, or x square by a square minus y square by b square equals to minus 1. Okay. Now the point is, like, first try to understand this thing. We have, like, if it is positive, okay, if it is positive, then your graph will look like this. If 1 is positive, okay, your graph will look like this section. Okay. Now if your 1 is negative, means horizontal function, and if your graph, if you have minus 1 there, your graph will be vertical hyperbola. Okay. So this is the graph. These are the graphs that you have to understand. Okay. For time being, please digest this situation so that we can handle these questions gracefully, and we can if there is requirement of struggling, we will struggle, but it will be little bit. I hope you understood all these things, and you will try to memorize the graphs along with the domain and range. Okay, so see you in the next session of Mathflix.